to provide current, accurate, and unbiased information on higher education in the USA. Education USA India remains your official source for higher education, and we encourage you to explore our verified channels for further resources and opportunities. It is now my privilege to introduce our expert speaker for today's session, Professor Rajiv Ganguly, the Malcolm McKinnon Endowed Professor of Mining Engineering at the University of Utah. Welcome, Professor Ganguly. Professor Ganguly is professionally interested in the big challenges related to mining, with his primary expertise being in the application of artificial intelligence and workforce development. He was previously with the University of Alaska Fairbanks, Jim Walter Resources, and Hindustan Copper Limited. He has executed industry and government-funded projects in USA, Mongolia, Saudi Arabia, Mexico, and Greenland, a truly global and impactful body of work. To learn more, you visit the website that is showing on the screen. Professor Ganguly, thank you so much once again for joining us today. And this is the agenda of the session that we are holding or hosting today. And we look forward to your insights on this highly relevant and future. Is yours, Professor Ganguly.
Well, thank you very much. Can you hear me okay, Professor Dr. Lahiri?
Yes,
Fantastic.
we can.
Fantastic. Let me share my screen. Are you seeing this okay?
Yes, we are.
Yes, we can.
Fantastic. All right. Well, good evening, everyone. It's a snowy morning here in Salt Lake City, and the snow plows are out here because we've had a snowstorm here. So just to give you a bit of feel for where I'm coming from, I'm really excited. All of you were able to take a moment to join this and decided to spend your evening with me here. So as we get started, my agenda for this talk, the nuanced part, critical minerals are all the rage. They are in popular media. And, I recently gave a keynote in Kolkata at a IIT Kharagpur event. And I mentioned, in our careers, we have never really had acknowledgement that mining is really important to society until the last maybe 10 years or so, where the world started realizing that you need mining, right? We would never would have imagined that prime ministers and presidents in the countries, in big countries, would actually acknowledge mining. And so, but here we are today, right? And so there's a lot of press coverage and around the world, and many things are now known to the public. And yet, when you look at critical minerals, there are a lot of underlying nuances that are not known. And so I thought I would cover the gaps of what is not discussed as much. And so I know some of you in the room are experts in mining and have been around mining for a while, and some of you are new. And so there'll be stuff in here that the experts will recognize and say, aha, yeah, that is true. And for those that are new to mining, you might be surprised to learn some of these things. So hopefully it'll all be a good use of your time. So with that, here is the critical minerals list. So what are critical minerals, right? And critical minerals, literally, just as the English would have you understand, it's minerals that are important. I will talk about the word minerals as well shortly. But these are important metals and so on and so forth that we need to sustain our society now. But these are also elements that we have a supply chain issue with. What does supply chain issue mean? It means that we are unable to source them easily now, or expect to do so in the near future. So we are expecting problems. And so, in fact, just this morning when I was staring at this, because this is the 2025 list, I noticed metallurgical coal. Isn't that interesting? And so not coal in general, but metallurgical coal. And I believe this is the first time I'm noticing this. When this whole issue of critical minerals started rising up, we would talk about rare earth minerals being important, and really people talked about 15, 20. And now I look, more than half the periodic table is on this list, right? 60 of them are in this. So that's very interesting. And so let's look at this and see critical minerals. Not all of them are the same. The issue is not the same. And so here is, let's get started with the rare earths first, because the challenges with sourcing rare earths is how this all started. And rare earths are still an issue. So I thought I would separate the rare earth discussion from the other critical minerals discussion to give you a proper perspective, right? So let's get going with that, right? So here you're looking. This is a photo of a very expensive plate of food in some five-star hotel in India. Doesn't matter where. And let us assume that this expensive plate of food is, say, 2, 3,000 rupees, right? And so the person goes there, pays that much money to enjoy this plate of food, right? And so this plate of food uh, has two goals. Clearly, the calorific intake is one value of this, but honestly, you're not spending $3,000 perhaps for the calorie itself. You want to enjoy the flavors and so on and so forth. And so, what's interesting is in this food that is worth several thousand rupees, if you do not salt this food, the the person eating the food will be fairly unhappy. I'm assuming the person enjoys a little bit of salt in their food. So they will not be satisfied at all. So one of the key elements of why they're having this food to enjoy the food, they're not getting it. And so yet the salt itself was perhaps 1 rupees or 2 rupees, right? Out of 3,000 rupees. And so therein lies the effect of rare earths, right? So when you look at the global effect of rare earths, I did a paper in 2018, and around that time we discovered that in $7 trillion worth of products, the quantity of rare earths in it was only $9 billion. So 9 billion in 7,000 billion worth of products, right? So it is exactly that salt and this expensive food, the biryani analogy. So small amount. And so what happens is, without the rare earths, many of the products that use rare earths will actually work, but perhaps not perfectly. And so that satisfaction will not be there. So I know all of you have smartphones. So at this moment, I want you to just touch the screen of your smartphone and notice how smooth that is. And that smoothness, is not because the rare earth is there. But that smoothness is essential, because otherwise, when you touch the phone will not function properly. So if it was rough, your response time with the phone would not be proper. As you're watching videos and engaging with the phone, the functionality will be affected. So how does it get that smoothness? To get that polishing, the metal used to polish, right? You're rubbing the glass with some metal. That metal needs to have rare earth elements. So see how indirect that was. If that metal did not have rare earths, the glass would not be polished as well, as well. But that aside, right? Uh, your phone itself has like 40 or 50 critical minerals in it. So that's very fascinating, right? So here you have a very expensive device. My phone is probably $1,500, right? And in there, the quantity of rare earths is very minimal. The value is not as much. And then the other thing I want you to notice in the nuance, you see dysprosium, samarium, and terbium in here shown. So the in that sprinkled salt, that little bit of salt, it's not just one element. There's actually several elements in it. And so The quantity of food is large, the sprinkling of salt is little bit, and the value of the rare earth in it is very little, right? And so two things I want you to get from this slide, which will keep coming back, is that it is the rare earth is important, and yet the quantity needed is very small and the value is small, right? So both of them. And quantity small means literally if one of us in the room could provide a little bit of rare earths, the world's problem could potentially just go away. So that is fascinating, right? Compare that to some of the other critical minerals, base metals. So right now, of course, my Zoom here is powered by electricity, and that electricity probably came to my house on aluminum wires. And so aluminum really, really powers long distance electric, right? Electric transmission. And so you take a look at zinc. Zinc is used everywhere, right? Our weathering and so on and so forth. Electricity is carried within devices and in short distances, like in homes and so on and so forth, on copper. So base metals, these are needed in much, much larger quantities, right? And so there's nickel, we all know about nickel, cadmium batteries, and lead is needed. And so what happens is now you have this other type of critical minerals. These are now needed in large, huge, huge mountains of quantity. We are no longer talking cute now, no longer talking salt. Uh, uh, Dr. Lahiri, are you still hearing me okay? Just a check.
Yes, we are hearing you perfectly okay.
Fantastic, fantastic. So there is, so this is so when you look at critical minerals challenges, that's where we are at. So very little needed. It's important. There is that type of demand, and then there is base metals type need. These are huge, huge, huge quantities, right? And so, okay, all right. So now let's move on to the next aspect of critical minerals, right? And so let's take a look. So what's interesting is, it is rarely that we don't know where things are. Okay, and so you see this slide, discovery to mine. You're seeing in here these icons, this hammer type icon. It's a symbol of mining, as some of you may know, or many of you may know, and so there are thousands of these. So you need thousands of good discoveries, and once you have them, perhaps one of them will become a mine. And so, depending on the source of literature, you will find this ratio is 1 to 1,000 to 1 to 5,000, right? And so, finding, it's very interesting to me. Newspapers get excited, like, Bufuf, we have this big discovery, we have this important discovery. Well, congratulations. Now you have 1 in 5,000, 1 in 3,000 odds of actually having a mine. So it's really the building of the mine that is difficult, and that is where the challenges are. And so let's see why you need to build a mine, why it is so challenging, right? And so you think about this. Building a mine will require money. So who will give you money? For that, right? And so you will always see, right? Whenever you have money, if I were to ask you, let us say I want 10 crores from you, you have a choice. You can give that money to me, or you just invest that in the stock market. And really, the only reason you would give to me is if you think you can make more money from me than from the stock market. And this is always going to be the background challenge in mining, right? And so, but before I can ask you for money, typically for mining projects, right, it's rarely ever that individuals open mine. You typically raise money from investors, right? And so individuals, maybe investors, or oftentimes it's the stock market. The company has stock and you sell stock. Where does that? What's the need to for you to know that? The thing is, most of the stock market, they have rules as to what you can say when you solicit money from investors. So they require hard data. So when I say I found rare earths, nobody cares. When I say I found uh, copper, nobody cares. You actually have to anchor your statement in hard data. So there has to be certain type of data, and based on that data, you have to go through certain um, certain technical processes before you can say you have $3 billion worth of copper or $500 million worth of dysprosium. Okay, and so you will notice the word resource and reserve. Resource simply means I have something. It really has no value. It simply means that, you know what, I have color on my hills. That's a resource. We have critical minerals resources. That means somebody found something and we analyze some samples and, there are resources. You cannot really say whether it is 500 million or 1 billion or 5 billion. There is no certainty to it. Reserve. That word has a lot of importance legally in many of the stock markets. So you go to the US stock exchange, to the Aussie stock exchange, to the Canadian stock exchange. Once you say the word reserve, you are offering some guarantees. And so what happens is to move that word from resource to reserve, you have to do a lot of due diligence. And so, for example, you need drill holes at that point. Not just drill holes, the drill holes has to be uh, spaced a certain way and within certain limits for certain minerals. So all of this means you need investors, right? And so you cannot just say, hey, give me $500 million so I can put 500 holes. Nobody will probably give you that much money up front. So what happens is you find color in your hills and you get excited. You're this front level, very early on geologist, and you go and some person that is highly speculative, right? They come and they say, you know what? Okay, I will give you enough money to drill maybe 2 drill holes. Let us see what happens. And so, if that drill hole actually confirms there's a lot of critical minerals, now you have a basis to go to the next set of investors, right? Uh, to go ask for more money to get the next set of money you need for the next set of drill holes, right? And so slowly you're building up, right? And during this time, right, the first person that invested in your property actually does not care about the mine. In fact, during this entire process, nobody cares about the mine till the very end. What does the first set of investors want? They didn't invest because the mine will be built. They invested because, you know what? If you find metals in here that are valuable, there'll be the next group of investors that will come in and they want to simply sell their interest in this deposit to this next person. So it's interesting in the early stages of mining, very few people, in fact, there may be nobody interested in the mine at all. They really don't care that down the road. They are simply their interest is in upscaling, upselling this deposit, right? And so during this time, though, the next set of investor will say, okay, you know what? You have dysprosium in here. I see. Okay. What is the price of dysprosium? Oh, really? It's this much. Oh my gosh, if what you're saying is true, I have $5 billion worth of dysprosium. You know what? Maybe I will give you $3 million. $3 million will probably get you a few drill holes, right? It is not enough to price the whole mine, but that is good enough for that time, right? But now, remember we talked about rare earths being a salt, right? Just a wee bit of salt. During this time, though, perhaps there is another country watching this. You put out a press release saying we have beautiful mountains with good colors in here, and so they decide, okay, so this dysprosium is worth so and so today. So they start releasing dysprosium into the market. What does that do? The price now gets tanked. So now there is a country, perhaps it is China, perhaps it's somebody else. They start screwing around with the pricing, and suddenly the price of dysprosium drops, And now investors are saying, sorry, you know what? Your $5 billion deposit is only worth $500 million. I am no longer interested in this. So you almost signed a contract for $5 million to put a few drill holes. That contract evaporates, and it may take you another 2 years after prices recover to to get the price back up. So you know what's interesting is during COVID, right? And so you all remember COVID, world economy tanked, activity tanked, uh, and so during this time, China was collecting all the extra copper. Remember copper, the mountains of copper? And so they collected a lot. They have a lot of money, and so they were just buying up the world's supply of copper. So tomorrow somebody comes up and says, you know what, we have financing to create this big giant copper mine. The value of copper is based on the pricing. Copper today is probably worth 10,000 or so dollars a ton. You drop the price, it drops down to 6,000, and suddenly your big copper project, the value of the copper just fell. So you release a little bit of copper into the market, it's done. Okay. So that is one aspect of this, the pricing and manipulation of that, right? The metals market, it's really, really crazy. Now let's talk about baseline infrastructure, right? So I did an interview with the New York Times. That interview never came out, but we talked about this. Uh, you found this massive deposit, boohoo, so what? If you actually only have copper in the ground and you have to get the copper out, you cannot email the copper to anybody, right? In fact, you can't even produce the copper unless you have perhaps hundreds of megawatts of electricity. Do you have that electricity at all? Or do I have to first build a power plant so you can build a mine? Oh, by the way, do you have roads to carry all this copper out? Oh, you don't. So now I have to build roads. Do you have ports? Right? So the baseline infrastructure is very, very important. Just because you found it does not mean you can mine it. So now you're realizing perhaps you needed $500 million or $1 billion in investment. Then you realize you actually need more like $2 billion because you have to build power plants and you have to build the roads. You can't just build a power plant. You need permits to build a power plant. So building a power plant in itself is a massive project. So now you're seeing all the problems you have to solve before you get to the mine, right? And each of these things will take perhaps a decade, right? You take a look at Donlin Gold, Donlin. This is in the middle of Alaska, and it's been known, massive, massive gold mine, right? Gold, of course, is now 5,500 an ounce, right? USD per ounce. Uh, But you know what? It needs power source. It's in the middle of Alaska, so you need to build all this infrastructure to even for the mine to operate, all the supplies that a mine need. For a large copper mine, it's not really about shipping the copper more so than shipping all the supplies needed to mine, right? So the baseline infrastructure is important, right? And so you can imagine that if you have to build a port, if you have to build a power plant, now what's happened is your pricing, yeah, you had $5 billion worth of pricing, copper. Maybe now you need $4 billion worth of investment to get the 5 billion. And now the investor says, I'm not so keen anymore. So you can see how one affects the other, right? And so by this time, perhaps you found these beautiful hills 20 years ago. It's already been 20 years, right? Aha, right. And now let us say slowly the mining company starting to come in the picture. And maybe, it's been you have had enough drill holes now where they can start building an ore body and building. The mining company says, you know what? It seems like this is actually real now. It's gone through the fantasy stage. There is perhaps now a 1 in 5 chance it will become a mine or 1 in 3 chance, right? So now the jurisdiction is important. Jurisdiction is actually the locality. What are the societal expectations there? What are the laws? And so there are two different things. Societal expectations is saying, what do they want in terms of remediations? What is the society expecting from this mine? Are they expecting jobs? Is that the only thing? Would they care if the mine is noisy? Will they care if there is, like, a truck going on the road every minute? Is there a problem for society there? What are the revenue sharing expectations? Does the society want 10% proper profit sharing? Do they want me to build them a hospital? Do they want me to build them? So you can see the jurisdiction itself, right, is an issue. How it complicates things. And even right in India, you look at the discussions in India. Society does have expectations, and so in some countries, perhaps in an authoritarian country or in a hugely underdeveloped country, a government can push through these things fast and not care for society. But in most parts of the world, society expectation, the laws, they become very important, right? And so you can see that that affects all of these things. So I take a look, right? So I've been involved in Mongolia a long time, and this Oyu Tolgoi deposit, right? A beautiful location, the Gobi, nice deposit, right? And during this time, Resolution Copper in Arizona, uh, similar magnitudes, right? The large copper deposits. Oyu Tolgoi has been under development for a number of years, whereas Resolution Copper in Arizona is still a discussion type of a mine, right? Will it happen in my career? I don't know. And so I've already been observing these things for almost 20 years now, 20 plus. The first time I visited Oyu Tolgoi, it was a advanced exploration project. Now it's, and the last time I went, right, there are trucks producing copper, right? And so, and yet in Arizona, this is still different. So you're seeing how the jurisdiction has made a difference, even though both of them are very similar in many respects, right? All right. So hopefully that helped you understand some things, right? So this sustained this part, investors come and go all the time. And I look at Pebble project. Anglo invested 600 million and then they decided to walk away from it, right? And so that project no longer has an investor. After a mining company invested 600 million, they decided it is no longer in their best interest, right? So, all right. So now let's talk about extracting and processing, right? So in my talk, you will notice I talk about the goal here is to talk about things that are not highlighted in popular media, right? So let's talk about extraction and processing. So remember, I talked about reserves. So for us to have a reserve, to use that word, we have to have a drill hole spacing, right? Certain drill hole spacing, certain tight controls. And let us say now the mining company is playing now. They're finally people serious about opening this deposit, and the geologist in the mine said, you know what? This is what we have here. We have drill holes and we have two deposits. You can see the brown and the tan deposit right in the lower left corner, right? Okay, and so what's interesting is this ore body itself is not real. Nobody really guarantees this much. The guarantees don't really apply to that extent. I'm showing you in here two little holes in here, and in here, this is just a mathematical interpretation. So now let me give you some additional nuance in here. So hopefully you can see my cursor. Let us pretend that these two drill holes are 50 meters apart. Okay. So now drill holes, this is exploration drilling. It's relatively close now. 50 meters is relatively close. And so this drill hole itself is maybe 5 centimeters in diameter. So 5 centimeters in diameter, 5 centimeters in diameter. In between, you have 50 meters. And there are several this 5 centimeter diameter spacing that the geologists have seen. And based on that, they built a mathematical model, right? So this whole brown shape is just a mathematical model subject to assumptions. So it is entirely possible that they will be wrong in their interpretation. Just because you have metal here and metal here does not mean the entire place is metal. So they try to take the best judgment possible, right? And they will build the model. But it is entirely possible there'll be gaps like the blue circles I'm shown here. There may be no metals. And I look a lot of technical reports, and sometimes I will smile and I look at assumptions made. I'm like, oh yeah, that's a very optimistic assumption, right? And so, what does an optimistic assumption mean? That their ore body looks bigger than what I think they will actually have, right? And so, this is a very interesting. So, it's also possible that there is metal here that the geologist has decided that they have not seen it because there is nothing in this drill hole, right? But there could very well be. But if the geologist does not think there is metal there, the mine may never actually go there because technically the metal does not exist. On paper, it has to exist. So, anyhow, the geologist has given this deposit to the mining engineers, and the mining engineers now build a mine. And here is a surface mine that you're seeing they have built. Notice how the surface mine completely skipped the lower left. For the mine to actually come here, the mine has to be really, really big and it will not be profitable. So even the theoretically you have this resource, it's not in the reserve, right? So it does not exist. The world will not see this copper at all, even though this exists, right? So you see the pie got smaller, right? You see this underground, you see this underground mines as well, the same analogy. Just because you have it in the ground does not mean it will get extracted, right? And so the pie got smaller. Now let's talk about the word minerals. So I worked in Hindustan Copper in Malanchkand in Balaghat in Madhya Pradesh, right? And so I would stand there at the mine, and we would look, chalcopyrite or chalcopyrite depends on how you. That was our primary copper mineral. So you have rocks and you have minerals and you have elements. So what is a mineral? Mineral is a fixed chemistry. So you see here copper CuFeS2. When this copper is given to you in nature and the copper comes along with iron and sulfur in this specific chemistry, CuFeS2, it is chalcopyrite, right? And then it will look in gold color. Okay, if it comes in an oxide form, you're seeing this Cu, it's a different chemistry. So now, of course, the copper. So when you're standing in a mine, you will notice in a copper mine, the copper can be gold color like that. And it's called fool's gold because some may think it is shiny, it's gold, and it's not. It's just copper, or it can look rusty like this, or in a green, not rusty. This green color. It's malachite, perhaps, right? It can be bornite. It can be any one of these. So here is the interesting thing, though, right? This is where the chemistry is important. You take this drill hole, you drill through this pile of rock in here, and you send it to the assay lab. The assay people will tell you perhaps that you have 0.5% copper. That's a typical grade in a copper mine, right? So basically, all they have done is they have collected all the copper you have, Cu, and they do not distinguish whether it is in CuFeS2 or this Cu2CO3, right? Malachite or this, right? But as far as a mining company goes, that is important because when they try to extract the copper, if they set up the processing plant to separate the Cu from FeS2, they are going to lose this malachite, right? So really, the assay lab told you have 0.5% copper, but you actually cannot recover the entire 0.5% because some of this is an oxide ore, right? And so oxide ore, for that, you do leaching technologies which are different. Aha. So now imagine a truck full of copper going, and you're thinking you're going to get all that copper. You're actually not going to get all that copper because as you try to extract the sulfide minerals, the oxides will actually report to your waste. So your pie got even smaller. Copper mines are lucky. Copper, lead, zinc mines, usually they only have maybe one, two, three minerals. They're very, very lucky, right? So their losses are not that much because their minerals, most of the minerals are going to be together. There'll be similar type of minerals, right? And so the chemistry games they play may not be that complicated, right? But not so if you're a rare earth. Remember that 1 rupee of salt you sold to this fancy restaurant. So now imagine your entire worth is 1 rupee, right? 1 rupee, maybe 2 rupees. You're a rare earth mine. This is the chemistry game you have to play. So your monazite mine, perhaps, right, in Orissa or Tamil Nadu or some place like that, it's a phosphate structure, PO4. So when you collect this monazite, right, rocks in here, rock is generic. It has all kinds of stuff in it, right? No fixed chemistry. So your mineral is monazite, and so it could be Ce, which is cerium, right? PO4, or it could also be lanthanum, La, right? PO4 or thorium, PO4. These are all monazite minerals, right? So what happens is as you separate out the PO4, the pile you have in your hand is a mixture of cerium, lanthanum, and thorium. Thorium is radioactive. So that is, of course, difficult. Now you have a problem in your hand because you have radioactivity, right? And so, of course, remember that smartphone? That smartphone requires a very specific rare earth element, right? So Ce is an element. Element is a specific element in the chemistry in the periodic table. So it's not a mineral. Monazite is a mineral. CePO4 is a mineral, right? LaPO4 is a mineral. And the reason they are in the brackets is because oftentimes they will all occur. You will get this together. So a mineral you pick up may have CePO4 or LaPO4. So in that specific chemistry, right? So this is very typical that you see in rare earth literature. You will find these parentheses, right? So now remember, you need to provide your customer with a very specific element, lanthanum or cerium. They cannot just take lanthanum, right? If you go to a jeweler, right, and you want gold, if they gave you gold, silver, and copper mixed together, you're going to be unhappy. You're specifically looking, right? So now to separate the Ce and lanthanum, here is the next chemistry challenge. They're all rare earth elements. They occur next to each other in the periodic table. What does it mean when you're neighbors in the periodic table? Your behavior is similar. You look the same in a chemistry game. So separating the cerium and the lanthanum is very difficult, right? And so this is like, separating two different types of grays, right? It's like trying to separate the browns on my suit in here, right? It's You have to use very, very nasty chemicals to separate the cerium from lanthanum. Okay, so remember the upside to this, you will only get 1 rupee or 2 rupees, right? Even though the product is worth 2000 rupees. So you are already constrained, and now you have to use all these noxious chemicals. And remember, we talked about the social license to mine, the societal expectations. Nobody wants nasty stuff in their neighborhood. You should look at uh, that deposit, the Linus property in Australia, right? And so it had radioactivity in it. It's a very common occurrence with monazites, right? And so Aussies would not allow that to be deposited. So they shipped the extracts to Malaysia. By the time Malaysians discovered that they were getting the radioactive waste from Australia, it was too late. The government of Malaysia had already signed all the contracts, right? And so, yeah, so when people realize that there is radioactivity in these monazites, will the people want those things? Disposed of in their area. So now the chemistry games, not only is it affecting your recoveries, is affecting your permits, right? And the pie got smaller. Now let's take a look at this AI generated truck with this copper in it. Okay. So now, okay, so Rajiv is standing in Balaghat. He has a truck full of copper in it. So the question is how much copper is in there? Ooh, one more nuance issue. So yeah, it's a copper mine, and let us just say it's chalcopyrite. Okay, so we have kept things simple. How much copper is in there? You know what? Nobody knows. The mining company does not know. All they know is, so now you have gone from exploration holes, which are 50 meters apart, to blast holes. You have to blast this. So, for example, a large mine will maybe blast half a kilometer wide block. Maybe it's 1 kilometer wide, and the drill holes are 5 meters apart now. Okay, so these are blast holes. Now the blast holes are bigger because you'll be packing them with explosives. And the blast hole, you roughly know the grade in there. Maybe let us say it is half a percent of copper in one hole, and the next hole has 0.2% of copper, and so on and so forth. But you know what? When you blast that hole, there's maybe several tons of rock that will be produced, and they will get loaded into the truck. So what is the copper content in this? Nobody knows. You have roughly have an idea, but it's important ideally to know how much copper is in it, because literally, if you think at this point that it has, say, 0.1% copper in it, just because you're in a copper mine, just because you're in a copper block, does not mean it has copper. You may decide that, you know what, this particular truck is waste rock. You may throw it away. You may send it to the waste rock pile. And if you did that, and let us say it had 0.25% copper, you actually threw away copper that was in the ore body that the ore body the people gave you. So technically, you have mined it and you have sent it to the processing plant in theory, but actually, you never got that copper because on the ground you decided there was a waste, right? And the opposite is also true. You may actually send waste rock to the mill and expect to get, right? And it's really important to know this. And so what's interesting is, and this is, I do a lot of AI work around mines in the world, and many times people will put analysis equipment on top, and you're seeing this chunks of rock are very, very big, and they might put an XRF or something like that. And look, it does not give you a good estimate of copper in there, and you might get fooled by that data point. And mines oftentimes think the more data you have, it's good. That's not true. You really need good data, not more data, right? And so if on YouTube you will see I gave a keynote in Peru and I talk about data challenges. But if this truckload is already faking you out, then it really affects how the mill is run, because the chemicals being added in the mill, it's affected by what you think is going through the mill. And remember, it may have taken you 30 years to permit your mine. That piece of rock that it took you 30 years to get to that piece of rock, it will be with you for maybe 10, 12 hours. So for a mining company, the challenge is, after 30 years of battles, the 12 years you have to extract value out of that rock, that better be very good 12 hours that you're spending, right, with the rock. Now let's talk about this. So uh, uh, here is a quick quiz question. This is the town of Daybreak, and it will seem weird I am talking about this, but I promise you it's relevant. Okay, this is the town of Daybreak, Utah. And so let me give you two quick snapshots. So I live in Sandy, it's nearby. This is roughly the type of things you will see in the town I live, right? And so you see beautiful parks and all of this. How many of you, if you are savvy enough, I'll give you 20 seconds. How many of you wouldn't mind living in a place like this? This is not a real estate advertisement, even though perhaps it is. Just, I don't know if they're allowed to respond. Just do a thumbs up or something, right? Let us see how many of you would live here. So maybe I'll ask Dr. Lahiri. Dr. Lahiri, would you live in a place that looks like this?
Absolutely.
Yeah,
Absolutely, yes.
yeah, yeah. It's beautiful, right? Yeah. Okay. Yeah, I see all these. You would live in this place like this. This is actually the red line train that I take to the campus some days, right? Let me ask you the next question. I asked the Danish, I was hosting a bunch of ministers from Denmark and Greenland, and I asked them, will you live in an area that is a mining disaster from environmental contamination? Dr. Lahiri, would you live in a place like that? That is a
No,
site of,
I would not want to.
you would not want to. Okay, how about this, Dr. Lahiri, if I tell you it's the one and the same? This is a site of environmental disaster. Yeah. So if you don't
Wow.
believe me, yeah, if you don't believe me, here is the next image. So this is actually a Google image I took from couple days ago. This is from outskirts of the mine. This is actually the view you see from, you can see even from my campus. It's not that clear. But here is you see a surface mine, right? So this is the Bingham Canyon mine. You can see it from the town of Daybreak. So outside of Daybreak is the Bingham Canyon mine. And this is one of the world's largest copper mine. And so in Hindustan copper, back when I worked at Malanchkand, we did 2 million tons of copper ore production a year. Bingham Canyon does, get this, 1 million ton of mining per day, right? Per day at 1 to 5 stripping ratios. It's a huge mine, right? And so this mine has been in continuous operation for about 120 years. So this entire area used to be mining, right? It has been mined. There's lots of contamination. In the 1970s, it became a huge, huge issue. This is all contaminated. When Rio Tinto bought the property, they did not want to be associated with a disaster. So they worked out an agreement with the federal government and said, you know what? Do not call it a Superfund site. Superfund is a technical term. It's a certain level of environmental disaster. They said, you know what? We will remedy this site for you. Please, please, please do not call this environmental disaster. So an agreement was sought. So then this whole town got remedied. This whole place got remedied. This is just a wilderness, right? Wilderness environmental disaster. It got remedied. Once it got remedied in the late 90s, early 2000s, investors came in and they said, you know what, this is remedied land. It passes all the environmental checks. Let's build a town. And voila, what do you have? You have the town of Daybreak. Imagine 25 years ago, none of this existed, right? And you know what? This is not a unique story. I worked in Alaska, as I said. You can fish in Fish Creek, which is outside of Fort Knox mine. It was again an environmental disaster. There is fantastic fishing in there, and these sites are monitored constantly for environment. Can you eat the fish? Yes, you can from those, right? So my point, though, is mining. People automatically think mining is leads to disasters, and I want you to change that frame of mind. It does not have to be that way, right? In the US, I will take you to places. In fact, I have done enjoyed. I've had my wife and I, she was my girlfriend back then. I took her out canoeing, and as we are leaving that, after canoeing, it says, hey, welcome to this blah blah blah. This used to be a coal mine so many years ago. So remediation is possible. The mining companies do a fantastic job. So it is entirely possible to do that, right? And so it is society does not have to compromise their standards to do mining. We can have both, and that is the purpose of this slide, right? Now let's quickly go to workforce, right? And so this is important. And so Dr. Lahiri and I were discussing my postdoc. He's now a fantastic faculty member in Anchorage now, and he's a biologist, right? And so I recruited him. He was in my team a few years ago. We were remedying tailings using bacteria, right? So mining has a lot of specialties. Many types of people can work in different aspects of mining, and so training is very, very expensive because of that. And this part applies no matter where you are in the world, because mining is also very interesting. Certainly in the Western world, right? When I work, at Jim Walters, my mine used to produce 6 million tons of coal. We had 450 employees. Around that time, Singareni Collieries. I grew up in the South. My father worked in mining. Around that time, Singareni Collieries, if I'm not mistaken, had 110,000 employees. They had 70 mines, and they produced 20 million tons of coal back then, right? About 20 or so years ago. 100,000 employees, 60 mines, 20 million tons. The mine I worked at, 450 employees, one underground mine, 6 million tons. You see the scale, right? And so what happens is in the West, anyways, very few employees. Everybody's niche specialized training is expensive. Training will be expensive in India as well as you train people in different fields, right? So in the first world country, this is a big issue, is aging workforce, a high turnover. I know some of you today are from mining companies. Imagine in your mind 40% of your workforce that you have today walked out this year. I have been to mines where the turnover is 40%. Now, true, that is in the high Arctic, right? In north of the Arctic Circle. But even in many mines that are not in the Arctic Circle, the turnover is 20%. 10, 20% is not that uncommon in mining at all. And so there's always this need to train workers, right? And so, yeah, because nobody wants, they have choices, and then you'll see why, right? And so that's a real issue. And then this is a survey in Canada, but this applies, right? 70% of the people unwilling to work in the mining industry. That is true in most of the Western world. They don't want to be in mining, right? And so one of the things we are hoping, this is a photo I took 10, 15 years ago in Indonesia, in Grasberg. It's, well, I tell you, if you get a chance, do visit Grasberg. It's a restricted area, but if you can get to visit, fantastic. This is a person, he's playing a video game on the screen. And so he's actually, so he's 1 mile underground. I'm 1 mile underground taking his photo, and he's operating machines that are 1 to 2 miles away, right underground. And so this was 10, 15 years ago. So automation, tele-remote mining, and we're hoping that some of these things will allow us to have operations. So just because your mine is in Balaghat, Madhya Pradesh, does not mean the operators have to be in Balaghat. Perhaps they can be in Raipur. Perhaps they can even be in Kolkata, right? If you're high-speed internet and so on and so forth. So yeah, I'm running out of time, so I'm going to blaze through these mining in the USA, right? So this is the critical minerals map. You see the western half, so I'm right here. Tons and tons and tons of critical minerals. Everybody has minerals. Many countries have critical minerals, and so having deposits is not a real issue. And I talk about this all the time, and journalists are always surprised about this, right? You don't find maps like this in India as much because India is not explored. Remember, the difference between having critical minerals and not having critical minerals is simply exploration, right? And so India only government primarily explores. They're changing the rules now, and so maybe India's mine will light up. But US has everything we need, right? It's there. We just don't have mines. We have minerals, right? And so the issue is this: USS is a huge economy, and it has everything, right? And so mining is a small part. I'll bet you when you guys think of mining, you think of giant trucks, you think of copper, gold, coal mining, right? But reality is, even in place like India, the biggest impact of mining in India does not come from the coal mines or from the copper mines, or in India, of course, iron ore or aluminum mines. It's really stone and aggregates. Really, all the roads that are being built in India or anywhere else, all the buildings, all the data centers that are being built for AI, they will require stone and aggregates. So you look at this: 70% of mining is stone and aggregates, right? The rest is metals. The point is, the mining is a small part of the GDP, certainly in the US. In Australia, I think it's 30%, right? It's a resource economy. So mining does not get any respect, nor does anybody care about mining so much in the advanced economies. And that affects many things. So that's why critical minerals and all this was ignored in the US until now, right? And so you look, US mining education is very small. We produce maybe 250 mining engineers per year, the entire US. So we probably produce 15, 20,000 mechanical bachelor's degrees every year, but only 250, right, per year. There's only 13 mining programs. As far as mineral processing goes, less than 10, maybe five or six. We have tons and tons of geology programs, right? But none of them are about economic geology, or mining geology, right? Most geology programs are about earthquakes and volcanoes and environment, right? And so where does the research stand, right? So it's interesting. US has probably the world's largest cadre of satellite researchers, and you all know this, right? So it's interesting, even as we speak, I'm discussing processes. So there are companies and governments involved in using my team, and by Africa and in other parts, I will not name these countries. And I was asking my team, hey, can we get satellite data for these countries where they're interested in involving us? And so it's interesting. My team member, she's laughing. She says, doesn't matter, throw a dart. If somebody says, can you do satellite work? Yeah, we can, right? Significant. And this is certainly an advantage that I have. That many others don't have. So, significant satellite resources, and then if I have friends and if I call them beautiful, they will probably let me tinker with the satellites as well and say, hey, I need this little bit of attention in this part of the world. Can you please, please, please direct this satellite here? Pretty please. And they may listen to me, right? So if you know somebody and that somebody knows somebody, you have that ability to do that, right? So we have that. From a federal government does some research directly. We don't have a mining research agency. So like, India has the National Institute of Rock Mechanics and CMPDIL and all these. We don't have anything like that. And so we have Department of Energy. The NIOSH does a very little amount of safety work. So we don't have a mining research agency. Most of the work that happens in the mining area is literally just processing. And there is a lot to mining than that. The US Geological Survey, of course, has lots of resources for earthquakes and stuff, and that is they have mining clearly. I don't see them as a research agency. They quantify, they do help with discovery, right? And so on that note, right? So you look, here is the discovery, and you see the pipeline getting smaller, the pie getting smaller. I'm making a pizza pie here, and then of course you're building a mine, and we saw as the mine gets built, the pie gets even smaller. And then finally, this last bit, the chemistry. The entire US research resource is in here, right? And that is because we don't have many mining engineers. And so all the research agencies, right? They're all chemists and biologists. So they see the world and all problems as a chemistry problem and a biology problem, right? And so we have massive amount of funding in mineral processing and metallurgy, right? And very little funding in other areas, mining, engineering, and geologies. And so the expertise in mining and geology is very spotty. So I have been lucky. I have attracted attention from around the world. So in some of the work I do, I look around and I feel like I'm at the cutting edge. I'm probably leading in AI in some aspects, right? But that is not uniform throughout. Unlike, say, in metallurgy, we have deep breadth and we have good breadth and good depth, right? In mining engineering, there's one or two people, one or two groups that are fantastic, and I wish there was more attention. So then you look at China, though, and so China is investing more strategically, and so they know that the pizza slice can be wider, and so if it was wider, perhaps the chemists and the biologists would have more to play with. And we're starting to make this argument in the US, and we're starting to get attention to this, right? And then finally, right? When AI comes in, people know that AI will require minerals, but they think in a very narrow way. They think, AI will need all this electricity. Okay, that is true. You also need for data centers. I mentioned this. But what they're not thinking is as people need more AI, right? So, for example, go to a mine and they have a camera system watching their employee to see if the employee is sleeping or not, because this employee is driving a truck. Or I want to use a AI doctor. I don't want to go to a doctor. And so to use a AI doctor, I need smart devices at home so I can get the heart rate and perhaps my blood pressure and all these things. All these smart devices will need minerals. And so no, critical minerals need does not stop with AI, electricity generation and data center. As all of you start expecting to use AI, you will use camera system and smart devices, and that will explode the use of minerals, right? And that's why this critical minerals challenge is so important. And I really feel so. AI is my expertise. I've been doing this for 30 years, far longer than many others. And I've been doing this at the front end with mining companies. So it's not just academic. So I have nuanced understanding. And I feel it all, the what cloud AI, you all know the AI company. I don't know if Siddharth is on here, Dr. Siddharth Agarwal in Indian School of Mines. He was my student. He and I did stuff 20 years ago. And I eventually published a paper worked on him. Cloud AI is doing that now, right? And so I look at that. Uh, the lot of the AI that is being done, uh, uh, you know, the if you rely on AI systems and so on and so forth, a lot of mistakes are being made, and we are publishing papers on this. So I feel the best AI will be when in mining companies, the domain experts start doing AI. With that belief, I actually released a software. It's being downloaded from 32 countries now, and this will help. If you're a geologist, you're a chemist, you're whoever you are. If you have a CSV file, this software will help you apply AI. And then if you not need training, we can figure out a way to train you. But there's manuals in here. Download it, use it, right? I really want people like you to be the AI, to do AI rather than using automation tools, because algorithms have problems in them for the nuances in mining, and there's lots and lots of nuances. And yeah, with that, I will stop. And I apologize. It took longer than I expected.
That was an amazing session, Professor Ganguly. It was really we got to learn so many things, and I think a lot of us will have a newfound perspective towards critical minerals and minings now. I mean, thank you so much. If you don't mind, can we stay back for maybe a few minutes and take two or three questions?
Yeah,
So
yeah, absolutely. Yeah.
great. Thank you so much. Audience, we request you to drop in questions in the chat box for Professor Ganguly to address. And in the meantime, Professor Ganguly, I'll ask you a few questions, uh, if that is all right.
Yeah.
Great. So, you were talking about the environmental impacts of mining, right? When you showed us the pictures.
Yes.
So, can you elaborate a little bit on what technological breakthroughs are most promising in reducing the environmental footprint of mining?
Yeah, and so all of this is relatively new. And so what happens is, the chemistry problem, right? So when you look at the environmental footprint, there is the hole and the other things that you make when you build the mine. So there's an environmental footprint from there. And then with every chemical, with every metal and mine, the environmental needs are different. So, for example, for if you have thorium in your rare earth deposit, you're dealing with radioactivity, right? So, how do you have a pile of radioactivity, and how do you confine it so that the radioactivity does not escape, right? And so one of the things, right? Uh, so I look at that in each of these cases. I don't know if there is a new whiz bang solution to all of this. In every case, we are using a mix of technologies, right? So with Internet of Things, right, you can have monitoring systems everywhere. So as soon as there is a crack somewhere, there's a seepage of gas, you can monitor it and quickly respond, right? So I look at things like that. And then you can actually address some of these things up front. So in the mine to mill space, in that mining space that I'm familiar with, you can perhaps do better and not send as much waste into the processing plant, because any waste rock you send to the processing plant will get seen by chemistry. And so things like that, right? So I would see this more as a collection of technologies than any one technology. So one thing I would like to mention is recycling. Recycling is not what it is. It's really, really hard to recycle. And everybody talks about recycling phones and this and that. And it's a separate talk altogether. And chemists will tell you different things, but there are real, real challenges, which is why recycling has not been a real solution at all. It maybe meets 1% of the world's needs, and I expect it to. And same with substitution. So you want to not use rare earths, and so it's been a challenge so far. And so, yeah.
Um, Professor Anguli, we have a question from Mr. Deepak Yadav. So
Okay.
he's asking if there is any opportunity for working professional from Indian School of Mines in your university or in the US um, as a whole.
Yeah, so the Fulbright program is there, and Dr. Lahiri, you're probably an expert in that because you guys organize the Fulbright program, and that is one way to fund. And so, as I showed you, funding is a real challenge, and now a lot of the rules they require you to be a U.S. citizen. But if you have your own funding and you can support yourself, certainly you can join any number of labs. And so there may be agreements between governments that might where one government funds their own scientists to go to another country, and there might be programs like that. But I'm happy to work with Dr. Lahiri and somebody else on perhaps a Fulbright application, and perhaps that can be a way to do collaborations. And then there's some other ways also you can collaborate, because one of the things I wanted to do is to perhaps develop a mining LLM where you stay in your places and I stay in mine, when we can jointly develop technology, certainly in the AI fields, and so that can be done.
Okay, that was really helpful, Professor Ganguly. We move on to our next question. So, the person is asking, dear Professor, as you had said, the economic value of the critical minerals is not that much, and the rarity of occurrence and greater control addition at greater gestation period of mining. How and why would firms invest tons of money and get that salt, which is essential and of less value or less premium?
Yeah, you basically hit the nail on the head. Why would anybody, right? Would I do this? And there is the thing, the real answer is everybody says, sorry, I'm not interested in it. I will give you a real example. I asked a junior. Junior is a company that is in the early stages. And they said, whenever we go to an investor, they say, look, if I give you this money, instead of this, I can put this in the technology sector and I get a 20%, 30% return next year. I don't have to wait 30 years. So it's a real issue. And so one of the things, I don't know if you like President Trump has, I think he's developing a framework to develop a $12 billion stockpile for critical minerals. So remember, not every critical mineral is not in, rare earths are cheap, right? But other critical minerals are not. And so, but yeah, that is a real issue. And so governments have to do something about this. You need your critical mineral, perhaps you give a pricing benchmark. You say, you know what, I guarantee this price. So there's various schemes governments are exploring from a policy perspective to get investor investment. And so you've also perhaps noticed that the US government has started to invest directly in some companies. So yeah, some of these have to be solved before yeah, this problem will be, solved. So yeah.
Our next question comes from Simone Singh.
Okay.
Simone asks that in deep underground operations, how are you managing seismic risks and rock burst potential as the stress field changes? Does that affect the economical strategy for the company?
It does. So, yeah, absolutely. So, I will not take the first part of the question because that's out. I'm not a rock mechanics expert, right? But I will do the second part. So, I will give you Oyu Tolgoi project as an example. It's a block caving operation. It's not super deep necessarily, but it's block caving, and block caving has geotechnical. That absolutely drives up the costs. Anytime it drives up the cost and it leads to uncertainty in production, it will absolutely affect the stock price of the company, and which affects the cash flow of the company. Absolutely. Yeah. And so, in resolution copper, heat is a big issue. It will be very, very hot because resolution copper is a deep mine, and it will affect, these are real issues. Yes. So there is a value in doing research in all of these areas if we can solve it. And so really on the heat issue, I just see that what companies have done is invest in massive air conditioners. And if it is very, very hot, you can actually use it for geothermal generation, right? You can, but if it is in the middle, it is hot but not so hot, then you are a problem because you cannot really use geothermal technologies to generate value. It's just hot, right? And so, yeah, it's very complex. Oh,
Aritra,
I
you are
cannot
on
hear.
mute.
Yeah,
Aritra, you're on mute.
you're on mute, Dr.
Sorry,
Lahiri.
sorry.
Yeah.
Yeah. Thank you for that, Mega. So our next question is from Professor P.K. Prasti, IIT Kharagpur. He says that Dr. Ganguly, earlier environmentalists used to oppose mining projects because they were polluting in nature. But for AI data centers, EV, and other such techs, there is demand of critical minerals, and we need to mine huge quantities of critical minerals. So my first question is, where are these critical minerals, and what happens to the concern of environment? I think you did address some of this in your presentation, but it would be helpful. You can speak a few more words.
Yeah, and I'm also seeing a question from Bala Madheswaran, Dr. Periswamy from Anna University, and he and I worked in Melanchthon together. And it's in a similar vein, right? The impacts and influence of mineral processing. He says the thing is, this is for society to decide. You decide how much risk you want, and so you have to understand that the need for AI is a societal need. But when you have an impact, you want a tailings dam, you are dumping chemicals, it's a local impact. So the society the local area has to agree or has to decide whether they want to shoulder the burden of the whole world, right? And that is that value proposition. So is it important for people in so and so city to suffer for the needs of humanity? And if this group decides, yes, we will suffer or we will take this risk, then what will the world do for them? Will the government, will somebody build a school, a hospital, or whatever, right? And so then, is it even suffering if you will build them a stadium? Is it even this if you remedy everything? So it is that give and take, right? And so this is a societal issue, right? And so this is a debate that is happening all around the world. Remember, the benefits are global, but the impacts are local.
Thank you, Professor Ganguly. I think we are running out of time, and maybe we can end with one last question. So, this is on behalf of the audience, that what new skill sets will define the next generation of mining professional?
Yeah, so I would say in the so when you look at mining, right, most people will be in the vocational level, operators and electricians and mechanics. So I was talking to Caterpillar, and so they have autonomous systems. So truck breaks down at a mine that is fully autonomous. Trucks are autonomous. The mechanics are unable to diagnose necessarily from a distance, right? So you have to be able to do remote diagnostics accurately. And so what will happen is you will find that a lot of the skill sets will now be technology related. So you will see the nature of the mine worker will change. I'm really hoping also how engineering is done will be changing. How mining engineers, I really want, just like nobody thinks that taking a calculus class or a geology class or a chemistry class is a problem if you're a mining engineer, right? Because they see the need. I want people to also look at AI. Do you know how much bullshit is in AI? People have no idea. And so I really want people to be more strong about their statistics background and the AI background and some of these understanding these things, because as engineers they have to know these things. And so what can be done? So I feel the nature of the mine worker at the vocational tech, they have to be more technology savvy. The engineers have to have skills beyond just being able to stand in front of a shovel. There is no need for people to stand in front of a shovel to be a mining engineer. They have to be using their brains a lot, and understanding the data that's coming out, deciding if the data is legitimate. Do you have the skill sets to decide? That truck that is displaying 300 tons, you have to know if that is actually a real number or if it is a sensor error, right? And so on and so forth. So yeah.
Great. So that was really insightful, Professor Ganguly, and thank you so much once again for sharing your time here, for sharing the knowledge. And we do appreciate and acknowledge that the audience have many more questions. So we will request them to reach out to any of these channels. They can reach out to India at educationusa.org, or they can reach out to Professor Ganguly He shared his email ID previously during his talk, and we do look forward to such learnings together and growing together. Thank you so much.
Thank you. Bye bye.